And another example problem, divide rational numbers. So you're going to find that dividing rational numbers is very similar to multiplying rational numbers. Once we have the division problem in place, we simply invert or flip the second fraction and then turn it into a multiplication problem. I'll demonstrate here. It says to evaluate the quotient. Again, we're given mixed numbers, -5 1/3 divided by -2 2/5. Now that property still applies. When we divide two numbers that are negative, our quotient, that's the answer in a division problem, will be positive. And again, we need to convert these mixed numbers to improper fractions. Thankfully, we're getting pretty good at that. So once again, our result will be negative. So I'm going to neglect these negative signs, knowing that in this problem, I really don't need to pay any more attention, knowing my answer will be negative. All right, 5 1/3. 3 times 5 is 15 plus 1, 16 thirds. A quick double check. 3 goes into 16 5 times with 1 left over. Sure enough, that would take us back to 5 1/3. Divided by 5 times 2, 10, plus 2, 12, over our original denominator, 5. And a double check, working backward, 5 goes into 12 2 times with 2 left over, so 2 2/5. Great. Now it's time to turn this into a multiplication problem. So we take 16 thirds, and we now multiply that by the reciprocal, or the flipped version, or the inverted version. Lots of ways to say flip that fraction, but the flipped version of 12/5, which is 5/12. And now we proceed as before. Cross-reduce, if possible. I can think of a common factor between 12 and 16. Right away I know they're both even numbers, so 2 would be a common factor. So I can think of dividing both of these by 2. 16 divided by 2 is 8. 12 divided by 2 is 6. Still evens. They still have a common factor. That tells me that I did not divide both of these by their greatest common factor. There must have been some larger number. And now that I think about it, that larger number is 4. Right? 4 goes into 12, and it also goes into 16. But that's okay. I can continue and complete this process in 2 steps instead of 1. So I'm going to do it one more time. Dividing 8 and 6 both by 2, I'll find 4 and 3. Notice, that's what I would have gotten right away if I'd simply divided 16 by 4 and 12 by 4. But again, completing this in 2 simple steps might even be a better method for some of you. 4 thirds now times 5 thirds. And since this got so ugly, I'm just going to rewrite my problem so I can be very careful. 4 thirds times 5 thirds. In this case, we have a common denominator, even though that's not required for a multiplication or division problem of fractions. That equals, no more things we can reduce, 4 times 5, 20, 3 times 3, 9, and once again the book has asked us to write our answer as a mixed number. I think that's going to be a common theme in this book, so we should always be in the habit of rewriting improper fractions as mixed numbers when performing work from the book. 20 divided by 9, 9 goes into 22 times without going over, leaving us a remainder 2. Right? 9 times 2 is 18. 20 minus 18 is 2. Our original denominator, 9. 2 and 2/9. A double check, working backwards just one step. 9 times 2 is 18, plus 2 is 20, 29th. And here we have one more guided practice problem that I'd like you to do on your own. -3 1/3 divided by -1 1/4.